Hi everyone, am I audible? Okay, great. Let's start. Can you all see the screen as well? Okay, great. Uh, so today I think we are going to start with linked list. Uh, like, can everyone just quickly brief what all topics you think you have covered? Like, not been covered in the class, but you think that you are now comfortable or okay with? Anyone? Graph, PFS? Graph was covered. I don't think graph was covered. Like, I meant from the winter camp. Like, have you guys gained some confidence in some topics? Maybe you would like to mention those. I know you need some more practice, but still, DP. Yeah. Tree stack. Okay, great. Yash. Others. Okay. DP. Okay. Cool. Like, I hope you got some base at least for some topics. Yeah. So, as I mentioned, today we are going to start with linked list. So, first of all, what is a linked list? Basically, it's almost like an array, right? Array. So, like almost exactly like an array, except a few things. What are those few things? Those few things are that uh, in array, the basically your memory is statically allocated. Whereas in linked list, it's dynamically allocated. What does that mean? So when you declare an array, you would have noticed that you declare something like array of 30. So this number is important because what the compiler does or what your OS does is books a space of 30, so 30 elements for you looking at this type. So if this is an integer, every integer can take, let's say, one byte, so it will book 30 bytes. Does that make sense? Yes or no? How array stored? So depending upon this number, it's statically allocated to the size. Okay. When we talk about linked list, we don't define the size in the beginning, but what happens is we can dynamically add or remove nodes. Okay. So how does that work? So what we say is every element is a node, just like in binary tree. If you remember binary tree, every node had two children, right? Left and right. Here we just have a pointer next to the next element. So there will be a pointer here, which will store the location or the memory of the next element. Then this guy will also have a pointer that will store the memory to the next element. Finally, this is the last one. It will store null, indicating that there is no more element in the future. Does this make sense to everyone? So every node, just like in binary tree was a hierarchical data structure. It had two pointers, one pointing to the left, one pointing to the right. Here there is only one pointer next, pointing to the next element of this linear data structure called as linked list. Is the difference making sense to everyone? What is an array and how is it different from a linked list? Others? Any doubts here? Let me know. Then I'll quickly move on. Okay. So next question is why linked list? Why do we need a linked list? We had an array. Why do I want that? Why do I want to complicate stuff? There must be some benefit to it, right? Memory utilization, yeah, that could be one, but something much more like easier to get, right? Some operations are faster, exactly. So insertion and deletion, let me have a look. So let's say I have in an array 1 2 3 5 6 7. I have a 4 that I want to enter here. How do I do that? I would need to move these elements, right? 7 will go here, 6 will go here, 5 will go here. Then there will be a space empty and I'll put 4 here. Does everyone get this? Yes or no? If I want to insert somewhere in the middle, even though I know the location, I still can't, right? I will need to move everything ahead and then put it here. Yes or no? Everyone? So this operation of, even though you know the memory, but adding an element there takes on. Let's compare it with linked list. So let's say there was a linked list like this: 1 2 3 5 6 7 null. What will I do? I want to insert 4 here. I will say this should now point to 4 and 4 should point to 5. So your insertion becomes O1 provided you know the memory of this 3. Is that making sense? How it becomes O1 insertion? I just need to put it in, like I just need to change 2 pointers. This was pointing here now, like I just need to change it here and then this guy will point here. So just 2 operations and that's done. I don't need to shift anything. Similar with deletion, if I want to delete something from here, what I can do is, if I know the previous one, I can just say remove this and add this and then remove this. So just cut off 2 and add a new one and that's it. Can everyone see that? Yes or no? Whereas here again, if you want to delete something, you'll need to shift everything to the left. So with linked list, deletion and insertion at random given point can be done in O1. But to reach there, it will be O time. Yes, that's why I've said random given point, right? That point is already given to you. Does that make sense? Okay, cool. Yeah, obviously, if you have to iterate and reach there, then it's O. There is no doubt about that. But I'm saying if it's given already. Okay. So let's define how a structure of this node will look like. So if you guys remember from binary tree, it's exactly the same. We'll have struct node. Then we'll have int data. And then we'll have node star next. Does this make sense to everyone? C++, this, Java and Python people will make a class and we'll have like class inside the class, right? For example, class node, and I'll say node object next. So it's like composition, like one node inside the other, inside the other, inside the other. So something like that, but it works just like linked list. Yes or no? Will Java and Python people be able to do it? Like slight differences, but it works almost the same. Yes or no? Cool. So now that we have defined a linked list, let's do one thing. Let's try to understand the main kind of patterns that we observe in linked list. So first thing, that first kind of patterns that are there is when you do pointer manipulation. This is the most important one actually, and the one which is used most frequently, where you need to do certain pointer manipulation so that your desired result is given to you. Okay, so I'll take a quick question and we'll try to see how, and we'll also try to write a small code for this. So let's say the question says we are given a linked list. Now, that means we only need one root pointer to uniquely determine a linked list, just like trees. Yes. If you have this is not called root in linked list. This is called as head in linked list. So it's the head of the linked list. So if you just know the head, then you can just iterate and get to the next one, right? Yeah. Okay. So yeah, what I was saying is pointer manipulation is important. So let's take up a question which says you are given a linked list, and what you want to do is you need to swap pairs of nodes. So what I mean by that is this is a pair, you will swap them. So 2, 1, then this is the next pair, you will swap them 4, 3, and then 5 because it does not have a pair, then null. Does this make sense to everyone, the question? Yes or no? Given a linked list, take pairs from the start and swap them. Okay. Others, can I get a yes if you are clear with this? Okay. Help me out. What can we do? What would be the first instinct? Temp node. Okay. Something much more simpler. What would be the first simple instinct? Okay. Right. This is the first instinct, right? I just change the data value. So what I can do is, so I can say node star current equal to head, while current does not reach the last. You'll take two things, currents data and currents next data, and swap them. So if your current next is available, then just swap currents data and currents next data. Is everyone able to understand this? Yes or no? And then I'll move the pointer. So current goes to currents next. Yes or no? I'll explain it again if you want me to. So what I'm telling you is that what simply we can do is just swap this one with 2, like just changing the data. 2 comes here, 1 goes here, 3 goes there, 4 goes there. So what I need to do is I need to start here, look at its next, and swap the data. So that is what I've done. So current is now head. If currents next is available, then you swap currents data and the currents next data. You swap these two and then move your current 2 step ahead. So current equal to currents next. So next and next. Is this loop making sense? Yes or no? A simple idea. Take the first, swap it with the next, then move 2 step ahead. Then take this, swap it with the next, move 2 steps ahead till you stop. Yes or no? Everyone? Is this making sense? Okay, one person has said yes. Others? You can type in a repeat or no if it's unclear. Okay. But what is the problem here? If current next does not exist, in that case, we are not updating the pointer. Yes. But okay, you are saying it will go infinite? Yeah. So probably you can write here, right? If current is not null and current next is also not null. Right, good point, actually. Now it's fine. Now I think I don't even need this if, but still. Yep. So Suraj is right. So he was saying when we reach here, we'll not even go ahead and it will be an infinite loop. So that's true. So we can avoid that by writing this condition as well. That till both current and the next are not null, then you go ahead with this. When to use current next not equal to null, current not equal to null? It depends on situation to situation. So here we are moving 2 steps, right? Can you see that? So anytime we are swapping or we are having a relevant thing to do, that is when both current and currents next are available. Can you see that? If both of them are not available, I'm not even doing anything. I'm just stopping there, right? So that is why I've written this, because both current and currents next are available, then only I need to do something. Otherwise, I just need to stop. So that is why this condition. Is that okay? You can make it in other ways as well. Like you could have removed this, and in else you could have just written break. That if current next is not available, then you break. That can also work in a similar way. So it's not about like as such when to use something. It's just about what you want to do, right? Okay, cool. But problem with this is that we are changing the data. Question says you have to swap the nodes, that is without changing the data. Does the difference make sense? So what the question wants is that, let's say this memory, this memory, this memory, this memory, they are connected like this. You change the connections. You want your memory to start here, point here, something like this, right? So it just wants you to change the pointers and not the actual values of the nodes. Does that make sense? So right, so the memories should stay the same. It's not like you are just swapping the, like you are keeping the pointers intact and just swapping the data. That is not required. You need to actually swap the memory locations and make sure that this is first, this is second, this is third, this is fourth, something like that. Does that make sense to everyone? What I need to do and how is it different? Okay, so how can we go about that now? What do you think? Some people are saying temp node. Can I do this? Can I create a separate linked list altogether? What do you think? So what I'll do is, I'll say I have a new linked list. I'll first insert 2 there, then insert 1, then insert 4, then insert 3. But again, that will create a new separate memory. I need to keep the memory intact. So that is also not a possible solution. If we get an updated list from 3 node, then we only need change first 2 pointers and return new head from 1 to null. Okay, that makes sense. Previous node could be used. Okay. Okay. So there are a few different patterns that I'll ask you to probably remember that are very common in case of linked list. So first pattern is, which we'll probably be using here, is to basically divide this list into 2 parts. So how are we going to do that? So if we look at it, what we read is 1, 3, 5, right? 1, 3, 5. It is exactly like this, 1, 3, 5. And 2, 4 is also exactly like this, 2, 4. It's just that the order is changed. Can you see that? Like their relative ordering, that is the odd positions, their relative ordering, and even position, their relative ordering are exactly the same in the last linked list. So 2, 4 was there, here also 2, 4 is there. 1, 3, 5 is there, here also 1, 3, 5 is there. So relative ordering of odd nodes and even nodes has not changed. Can everyone see that? Yes or no? So in such cases, there are a few more questions which have a similar thing where relative ordering of some nodes is same in the output and other nodes is also same in the output. Why it is happening? Because we are only swapping these two. So this still remains the same, and similarly this also will remain the same. They'll not change. Repeat please, relative ordering. Short, I'll do that. So what I'm saying is, if I am swapping like this, right? Let's assume there is a huge list also, and I'm swapping like two pairs. Then also this first will be before this third, and this will be before this fifth. Do you agree? Because they are being swapped in pairs. So 1, 3, 5 will always be in this order. It will not be that 3 will come before or 5 will come before 3, something like that. Do you agree? Yes or no? Right? Similarly, when you look at this 2, 4, again, their ordering will also remain the same in the final output because they are not being changed with each other, right? The even positions. Yes or no? Yep. So in those cases, I'm saying we can divide the list into two parts, one having the odd positions and one having the even positions. So what I can do is I can simply say any nodes next will now point to this nodes next to next. That is, I will remove this, point it to 3. I will remove this, point it to 4. I will remove this, point it to 5, and remove this, point it to null. So what I have done is I have split the list into two parts, one with the odd positions, not odd numbers, odd positions, which is 1, 3, 5, null, and 2, 4, null. Are you able to understand this? How we are doing that? I'll also write the code for this, but do you understand the logic? So what I have done is I have taken these and separated them out, and taken these and separated them out. Everyone? Is this making sense what I'm trying to do here? Then I will interleave them in the opposite order. So what I'll do is, just like I separate it, now I'll combine, but take this guy first. So I will combine it like this, like remove this, add here, remove this, add here, remove this, add here, remove this, add here, and so on. So 2 first, then 1, then 4, then 3, then 5. Just like merging. If you remember, if you have done merge sort or some stuff like that. So I take one from the bottom one, then one from here, then one from here, then one from here, and so on. Is the idea making sense? So splitting the string with odd indices, even indices separately, and then recombining it by taking the even ones first and then odd ones. Yes or no? Okay. Let's write a quick code for this, right? And see if we are able to get there. So let's say I have my head of the node. So let's first try to split it. So when we split it, we will have head 1 and head 2, right? So let's say I create head 1 as head. What will be my head 2? Can you point out? Look at this list. This will be my head 1. What should be my head 2? Yeah, heads next. Everyone agrees? Heads next. This will be my head 2. Right. Okay. Now what do I need to do? So while head is not null, ideally I need to just do head equal to heads next next. Sorry, heads next. What am I doing? heads next needs to be heads next next, right? That is heads next needs to be heads next next. That is, remove this and add this. Yes or no? Is this part making sense? Not completely, like there will be a few more things, but does this make sense? So basically, I'm saying any nodes next will be that nodes next. Problem is, now that this has been changed, how to move ahead to this, right? I can't do that. So I need to have a temporary in the middle, which is heads next, and say I'll move to temporary now. So head becomes TMP now. So these two are for movement, because when I remove this and add this, I have no way of knowing 2. The only way to know 2 is by storing it in a temp and replacing it here. Does this idea make sense to everyone? Yes or no? So this is for changing of pointers, and this is for that part. Yeah, you can write all those if things. I'll do that also in a moment. But yeah. But is overall this making sense to everyone? I'll look at when we need to stop. Can you please repeat the last 2 steps? Sure, I'll repeat it. This was 100% clear. This was 100%, right? So with this, what I'm trying to do, I'm saying I'll go over all these elements one by one and change its next to next, right? That is what I've written. Heads next becomes heads next next. Does this much make sense? Then I'll talk about these 2 statements, but does this much make sense? Right? Now, once I have replaced this, I need to go to the next one, but I have cut this off. Like in general, if this connection was there, I would have just written head equal to heads next. I would not need a temp. But because this connection is now gone, to reach this, I need to store this somewhere and then go back to it. So that is what I've done here. I have said I'll store it in a temporary variable and then make my head as temp so that I can continue from this point. Does that make sense now? Because otherwise, if I write head equal to head next, it will go to 3 now, but I need to go to 2 and I have no connection to 2. So I need to store it in the temp before and then directly go to 2. That is the only part. Does that make sense? Right. Let's come to when we need to stop. Okay. So when I am at 4, I will say force next is force next next. This will work. But when I am at 5, I will say 5's next is 5's next next. I can't do that. It will be a null pointer exception. So I need to stop at 4. How do I stop at 4? That means I need to stop when something's next next is null, right? So till the point when something's next is not null, you continue. That means if the next is available, then continue. If the next is not available, then you stop. So this condition will slightly change. Does that make sense to everyone? I need to stop at 4. I can't go to 5 because when I write this for 5, that 5's next is equal to 5's next next, it will be null pointer. So I can't do that. So I need to stop at 4. So if I want to stop at 4, I will write this condition. That stop wherever you are getting next as null, right? Does this make sense to everyone? So see, don't in linked list, don't try to remember that, okay, we'll in this case we'll write this condition. That will never work out. you need to look at a situation, and it's very easy to figure out from a test case that where do you need to stop, right? In general, unless it's something complicated. Is this making sense to everyone? Others? Can we move on? Okay. So now we have separated the two lists. What is next? We'll come to that. If we have to stop at 4, then head next. So heads next is null here, right? Do you agree? Sujay? So what you can write is, if heads next becomes null, break. That is a possible solution. Or what I have written is, till its next is available. So when you reach 5, you need to actually break, like stop from there, right? So when its next is not available, then you stop. Am I making sense? So it's just about if you want to stop at end or at the beginning. So I am stopping when I reach 5. If you want to stop when you are done with 4, you can write an if here, that if now heads next is null, then you stop. Is that okay? Yeah. So it's just a choice. Where do you need to, like, basically stop it? Okay, cool. Yeah, what I was saying is, now we have got two lists that look like this, and we need to combine them. That is, head 2 first, then head 1, then this, and so on, right? So how do we do that? Again, I'm not writing termination right now. We'll see what the termination is. But I'll write the common case first. What do I need to do? If I have head 2 and head 1, I first need to point head 2's next here and head 1's next here. Do you agree? These are the connections that I want to make. Break this, point it here, and then break this, point it here, and then move on to these two. They will make their own connections. Yes or no? Do you agree? Okay. Some people get confused how to know which connections to make in current loop and which in next. So in principle, what you do is, the nodes that you are currently on, their next you figure out, and then give out the baton to the next nodes in the line. So as an example here, I will make sure that pointers of 2 and pointers of 1 are in place. Then I'll pass on the baton to 3 and 4 that you figure out yourself. Okay. So as far as 2 is concerned, its next should go here. And as far as 1 is concerned, its next should go to 4. Okay. So which of the two connections do you think I should make first? 2 to 1 or 1 to 4? Again, it's a matter of choice, but still, if you can see a small benefit here, should I make 2 to 1 first or 1 to 4 first? Okay, everyone is saying 2 to 1. Just a small thing, like you can figure it out later also. But when you want to make, as soon as you break this and make 2 to 1, can I see 4 is lost? Yes or no? Unless I store it in a temp, this 4 will be lost. As soon as I break this and make this 2 1, this 4 is lost. We can store it in temp, right? That's a possible thing. But generally, we try to reduce as much space as possible, right? So a better idea would be to make this first, right? So that 4 is not lost, and then move this. Am I making sense? So what I'll do is, I'll say head 1's next will go to head 2's next. Do you agree with this? Head 1's next goes to head 2's next. Yes or no? Then head 2's next goes to head 1. So we have broken this, made this, then we have broken this, made this, without any temp variable for now. Now the only thing is moving head 1. I can move head 2. Head 2 can be just moved by head 2 equal to head 2's next. I can move it to 4. But moving head 1 is difficult because it's at 3. So how to do that? I need to store this in a temp. So node star temp equal to head 1's next. And I'll say head 2 goes to head 2's next, and head 1 goes to temp. Okay. It might look like a little complicated, but just if you make those diagrams in copy, then it will be relatively simpler, right? What we are essentially doing is breaking this, moving it here. That's this. That head 2's next is head 1. Head 1's next was head 2's next previously. So 1 to 4 is made, 2 to 1 is made. But now, because 1 to 3 was broken, 3 is lost. And we need to move to 3. So that I have stored here so that I can directly move there. 4 is not lost. 4 can be found by this next. So that I have done here. So we needed only one temp to make these pointer manipulations. Is the idea making sense? Yes or no? Okay. Others, any doubts here? Any statement which is not making sense to you? You can just type in if you want me to repeat any of it. I'll happily do that. Then we look at where to stop. Again, the only important thing is making sure your pointer manipulations are on point. You don't do some random manipulations. 5. Okay, sure. So 5 is linked with 1. Okay. I'll do 2, 3, 4 and tell you what happens, right? Do you agree this was our state at the beginning? Dheeraj? This was our state at beginning. This is head 1, this is head 2. Okay, let's do it step by step. Head 1's next is head 2's next. So head 1's next is head 2's next. This has happened. Can you see here itself 3 is lost? When do I need 3? When I am done with 1, 2, I'll move to 3, 4. But 3 is lost. So that I have stored here. Does this make sense? Why I have stored it at 1? Because it was lost right now, because it has changed. The next step, head 2's next is head 1. So head 2's next is head 1. So remove this, add this. Can you see? Okay, the answer is removed, but basically 2, 1, 4 is done. Yes or no? 2, 1, 4. These connections are made. That was the initial one. Right? Next, head 2 equal to head 2 next. Now I need to pass on the baton to 3 and 4. Like, and tell them that you figure out your connections. 1 and 2 are done. 1 and 2 have figured out their connections because 1 is connected to 4, 2 is connected to 1, which was the intent. But 3 and 4, now you figure out yours. So how do I pass it? I say head 2 now becomes 4. So I've written head 2 equal to head 2 next. And head 1 now becomes temp, which was stored. So head 1 becomes this, head 2 becomes this, so that they can figure out. Now this is no longer in picture. In a way, I'm just merging these two. Now is it making sense? Completely? Okay, cool. Okay, now when to stop, right? Let's say 3 and 4 also figure out their connections. So this 4 goes here. This 3 now points to null. This is what will happen. 4 points to 3, 3 points to null. Yes or no? And I'll say I'll go to null and 5, which is already bad. I can't go to null and 5. That does not make sense because it will break on right? So ideally I can stop as soon as one of those become null. So either head 1 becomes null or head 2 becomes null. So if both of them are not null, then I need to continue. Does this make sense? Right? So 3 4, after 3 4 I go to 5 null. This is already bad. I can't change null's pointers, so I need to actually stop here. I can't go ahead, right? So I will stop as soon as I reach some place where one of it is null. Okay, now let's look at different cases that are possible. So let's say there were 1 3 5 null and there was 2 4 6 null. So in this case, when I change the pointers, both of them will be null. Can you see that? Like I basically head 1 head 2 would have been 1 2, they would have figured out. They would have been 3 4, they would have been 5 6, and they would have figured out. Then both of them are null. Can you see that? Yes or no? In when both of them are of equal length. In this case, I don't need to do anything. This is already sorted. Yes or no? If both of them are null, that means everything is already sorted. I just need to return the starting head 2, right? Can everyone see that? Yeah. If they are not the same, like in this case, what is left? This 5 would be hanging around, right? One of the list would be hanging around. What do I need to do? I just need to add it at the end. So how do I do that? I will simply iterate and at the end add this 5. Is that okay? Yes or no? Just this will be left, right? This 5 which will be hanging around. So I'll just iterate and add it at the end. Okay. If you want to save some time, you can store the end and then directly link it. That's up to you. That's a small optimization. If you don't want to iterate again, every time in this loop, you also store in the end, and then that just directly link end with the 5. That's up to you, right? But 3 is pointed, yeah, exactly. So we'll not point it to null, but point it to 5. That is a change that we'll bring about. Okay. So iterate till you reach a node which is pointing to null, point it to 5 instead of null. Can't we use head 1's next is null? You can do all those changes. I'm just telling the most simplest thing that is seems understandable, right? That's up to you. If you want to complicate it, that head 1's next is not null, there you stop. You can do that. That's up to you. Okay. But this could also be one possible way, right? I'll just let it happen, and then at the end, just plug in this 5 at the end, whichever is left, right? That's what we do in merge. Those of you have done merge sort, we one by one merge them till one of the array has extra elements left, and we chuck them at the end, right? Same I am doing here, just merge one by one, then whatever is left in one of the case, just put it at the end. Does that make sense to everyone? Tell me one more thing. Can ever the bottom list have more elements? What do you think? Can it ever happen that the bottom list has more elements? No, right? It cannot. It cannot happen. Why? Because we are literally taking odd ones first, right? So yeah, so it can be either even or odd. If it's even, then they are equal. If it's odd, then first one has one more than the next one. Okay, cool. So that is about this particular question. You can implement it. I will also post it on the group. So this is a complicated question. It's not a very straightforward and easy question, but I've taken it so that we understand pointer manipulations in a really good way, right? Okay, cool. Let's take up one more pattern and one more question on that. So apart from pointer manipulation, there are a few more common things that we do in linked list. So one thing that we do is using slow and fast pointers. So I'll take up one or two problems on that and we'll try to solve them. So first one, which probably everyone would have done, is finding middle of the linked list. Right? So let's say you have a linked list of size 5. You need to find the middle node. Oh, I have written of size 6. So in size 6, you would run the first one. But if you have size, let's say 3, you return the middle node. So simple question, given a linked list, just find the middle node. Okay. We'll see how we go about it. Vikas, were you asking some question in the previous one? Yeah. What was it? Let me know. Others think about this, how we can go about it. Although I've already given a hint. Two pointer. Yeah. Yeah, that could also be a possible way, Tanush. Great idea. Can everyone read Tanush's idea? That is the first thing that you should say actually in an interview, because that's something which is very much more easier than what you guys are suggesting. Like to change the pointer as the question says. Change the pointer as the question says. Yeah, but that will be a lot tougher, like according to me. So why will it be tougher? Like what you need to do, then you will figure out this 1 3, then you'll change this to here and then move on, right? Are you saying this, something like this, that you take pairs of 2, change this? Yeah, you can do that. Ideally you'll be able to do that, but I just wanted to point out these two are common patterns, right? One is splitting and one is combining. So these two are common patterns that happen throughout in linked lists, right? Okay. Yeah. So I'll post some more questions where this is very clearly visible that you have to do these two patterns. Yeah. Moving on to this third pattern, which is slow and fast pointers. So one thing which Tanush is saying is the easiest one, which he's saying that I'll start here and count. So 1, 2, 3, 4, 5, 6. I know 6. I divide by 2. I get 3. I find the third node. Then here also 1, 2, 3. Divide by 2. 1. So actually I need to take seal here to get 2. Then I'll go to the second one. Does that make sense to everyone? Simple. Just iterate, count. You'll get x, divide by 2. If it's odd, plus 1. If it's even, then as it is, and just find that particular node from the starting. Everyone, does this make sense? Count and divide by 2. Okay. What is the time complexity of this? Right, on space complexity 1, right? So yeah, n and 1. I don't think we can do better than that. The only thing that your interviewer might say is that you have to do it in one iteration, right? One iteration. Okay. Although that's fundamentally wrong, because when you use 2 pointers, you are ideally doing 2 iterations. It's not like you're doing 1 iteration, and the time and space also remains same. So this solution and that solution are very same, right? I don't see any difference in it. Okay. Essentially, when you move slow and fast pointer reaches the end, slow reaches half. So ideally you are doing the same thing. But interview is an interview and you can't argue. So what you suggest is the slow and fast pointer that we'll discuss. We have to run 2 loops, first for finding the size and second for finding the elements. It's 2 loop, But essentially you have just combined the two loops into one, right? When you do two pointer, because any which ways, first one is going to the end, just like calculating size, and second one is going to half, just like finding that element, right? You just combine those two loops, but essentially the number of iterations is exactly the same. It's not like that is taking less iterations. Okay, cool. But I will tell you the idea. So what is the idea? What we do is we put two pointers at the beginning of the array, right? And what we say is that there is a fast pointer and there is a slow pointer. Okay, so fast pointer moves 2 steps and slow pointer moves 1 step. Okay, so if I do one iteration, fast pointer moves 2 step here, slow pointer moves 1 step here. Then fast pointer moves 2 step here, slow pointer moves 1 step here. Fast pointer moves 2 step, I reach null, so slow pointer is my answer. Simple idea. When fast pointer, which is moving double the amount of slow pointer, reaches the end, that means your slow pointer must have reached the middle. Does that make sense? Right? It's simple, like you and your friend, one friend is like making 2 steps, you are making 1 step, so obviously when he reaches the end, you'll be halfway through, right? That's a simple logic. So same idea we can use here, slow and fast. Fast pointer moves 2 step, slow moves 1 step. Fast pointer moves 2 steps, tries to move 2 step and reaches null. Slow pointer is the answer. Okay, so that is the simple idea of finding the middle of a linked list. Is everyone clear with this idea? Yes or no? I'm not writing a code for this because it's relatively really simple. So just try it out yourself once and then let me know if it's unclear. What I'll do is, on the same approach, take up another tougher problem and we'll try to understand it from scratch. Which is detecting loop in a linked list. So let's do that. So let's say we are given a linked list which might contain a loop like this. You need to find if there is a loop or not. So a linked list might have a loop, might not have a loop. You need to figure out whether it has a loop or not. So how does a loop work in a linked list? Remember, in a node, you only have one pointer. Do you remember this? Yes or no? So it's never possible to have two nodes linked, right? This is never possible that we'll have two nodes linked. So how does a loop work here? Loop will work only if like they are connected in a cycle, like one points to the other points to this, right? That is the only way. It can never happen that it's like this. They both point to the same. So because same nodes two cannot originate, this kind of stuff is never possible. Is that clear to everyone? Okay. Right. So there is a difference between graphs loop and a linked list loop. So those of you who have done graphs would know this is a very much a possibility in graph, but it's not possible in linked list. Okay. Moving on. How can we go about solving this? Anyone? Any initial ideas? Okay. There are a few. I'll read them. Yeah, if slow and fast meet. Why, Surya? Can you tell why? Set, if we get the same node next time, it means we have cycle. Great. While traversing, we can store address of node in a map and see if right, exactly. So what we can simply have is a set of all the ones that are visited. So I visit this, I put it in the set. I visit this, put it in the set, so on and so forth. If I ever get a node which is already visited, then I know that it's a loop. Does that make sense to everyone? So I can have a set or a map kind of thing or any storage which tells me what are the unique elements in it. Okay. So I put this, whichever I'm going through by iterating, I just put it in the set and I check before putting, have I already seen this element? If yes, then I'll just say it's a loop. Okay, but why, Surya? Why? That's what I'm asking. Why they have to meet? Can we prove that basically? Anyways, I'll prove that. Don't worry about it. So for this, I'll write a quick simple code. We'll simply have a set and I'll say while. So let's say I have my pointer head. While head is not equal to null, you keep on going. So you check first. If your set already contains head, that means it's a loop and you break. Otherwise, you just add current head to the set and move on. Head equal to heads next. Does this make sense? Create a simple set. Whatever node you are visiting, add it to the set. Keep on going. If before adding, you see that it's already there, that means I've already visited this. That means it's a loop and I'll break. Does that make sense? Yes or no? Everyone? Okay. Cool. But what is the problem here? Can you tell what's the time and space complexity here? Right. We are taking an extra on space. This is the problem. Time is still on. We are just going over it once. But set space is on, which is the worst. So we need to improve on space and we can do much better than this, that I'll talk about. So again, we use slow and fast pointer approach and let's see how. So let's say I start 2 pointers here, slow and fast, and we'll do our general thing, that is fast should move 2 times, slow should move once. So if fast moves 2 times, it reaches here. Slow moves once, it reaches here. Then fast moves twice, it reaches here. Slow moves once, it reaches here. Now can you see that both slow and fast have entered the loop in this particular case? Yes or no? Do you see, like, after 2 iterations, they have both entered the loop? Everyone? Yes, no? Can you see that much? Okay. So can I say now they'll never leave the loop? Like if I keep continuing, moving fast, moving slow, moving fast, moving slow, they'll just stay in this loop. They cannot ever go out if it has a loop. Yes or no? Everyone? Okay. But how we sure they will meet? Yes, I'll talk about that. That I'm going to talk about next. But can I say that they'll stay in the loop first of all? Okay. Let's look at the distance between slow and fast pointer. Okay. Right now, from one side, the distance is 1, 2, 3, 4, 4 nodes. And from the other side, it's like 1 node in the middle. Do you agree, everyone? Listen carefully here. then you'll be able to get it much better what happens. Everyone with me till now? Okay. Now let's take one more step, move the fast pointer twice and slow pointer once and see what happens. So fast pointer moves twice, 1, 2, and slow pointer moves once here. Now if you see, the distance from the one side between them has become 2, and from the other side it has become 3. Can you see that? Yes or no? From 1, 4 it has become 2, 3, right? By because one guy took 2 steps ahead, the other guy took 1 step ahead. So although the direct distance between them has increased, because it's a loop, the other side distance has reduced. Let's extrapolate it. Let's go one more step. What will happen? This will become 3, this will become 2, then this will become 4, this will become 1, then this will become 5, or from one side the distance will become 0 and they have actually met. Can everyone see that? That their distance will be slowly closing off in one direction and they'll have to meet at some point or the other. Everyone? Does this make sense? I'll repeat it quickly. So I'm saying when they entered the loop, this was fast, this was slow. From this side, the distance is 1. From this side, the distance is 3. Now, when this guy takes 2 steps ahead and this guy takes 1 step ahead, the distance increases. That's obviously true, right? If one guy is fast, one guy is slow, the distance increases. But because it's a loop, the other side distance decreases by 1. Because it decreases by 1, we can say it will end up being 0 at the end. So it's not just about one making 2 steps, other making 1 step. Even if one of them was making 3 steps and other was making 2 steps, still they would have met, right? Because the distance will be again closed by 1 unit. Can everyone see that? If this guy took 3 steps ahead, this guy took just 2 steps ahead, that means still the distance between them will be closing, right? But this cannot be said with 4 and 2. Why? Anyone? Why? Yes, changes of 2 units. Can you see? Like if the initial distance is, let's say, 1 node and 4 nodes, it will change by 2 units. So from 1 it will go to 3, from 4 it will go to 2. So it might not ever get to 0. Can everyone see that? Yes, if slow is 2, fast is 3, it will work, right? Why it will work? Because the gap difference that happens is of 1. Okay. Yeah, not exactly jump difference should be 1. Actually, it's related to co-prime. But for that, you need to go a little bit deeper into modular arithmetic. But I'm just saying, if someone asks you, is 2 and 1 the only speeds that are possible? The answer is no. Even when we do 3, 2, 4, 3, 5, 4, these are all also possible. Okay, there are some more, but for that we need to get into detail of modular arithmetic. So we won't do that. But at least this much is very, very easier to spot, right? Is everyone clear with this much? How to detect a loop? So basically what you do is you keep on running slow and fast pointer. If they ever meet, that means that there is a loop. Okay, so simple idea. Everyone clear with this? Yes, no, repeat. Okay, awesome. So this was about slow and fast kind of step. I think these are the most common patterns. One more is reversal. How many of you know how to reversal English? By having 3 pointers and pointing it backwards. So there are 2 videos on the dashboard. Reversal linked list iteratively and recursively. Okay. Important questions, must do. So please watch over them. I'll take up a little complicated problems and try to do that. Start point of the loop, again, that's also very simple, but uska proof, like the proof of that has to again be related to modular arithmetic. So I'll not do the proof, but what you just do is, after they meet, you say fast pointer goes at the beginning and you start one by one step. You can just read about that theorem, right? And you can also read about the proof if you want. Sujay, is that okay? So actually there is a modular arithmetic chapter. If we would have covered that in this winter camp, then I would have been happy to discuss the proof also. But right now it would be over the head of many people, right? So probably not a very good idea. Okay, cool. So yeah, as I was saying, please do these. I'll take up one more interesting question and we'll try to solve it together, and then we can break off for today. Okay. This question says that let's say we are given a Y-shaped linked list. Right? It's a perfect Y. We need to find the intersection of it. LRU cache is related to doubly linked list. And it also includes some more structure like hashing. So we've not covered all of them right now. So there is not much point in discussing it right now. Okay. Yeah. Anyways, the question says that let's say we are given a Y-shaped linked list. We want to find the intersection of it. Everyone, is the question clear? Yes or no? Okay. So we'll be given two things. The two heads for the Y-shaped linked list. What can we do? What could be the idea? Yeah, hash map is one. Let's not do hash map. Yeah, set and hash map is obviously the one, but let's not do those right now. Measure length. Okay. Something very simple. It's a perfect Y. Can we not do something very, very simple here? Exactly. Exactly. So what we can do is we can just iterate. So we are here, we'll go one step, we'll go one step. If they meet, that's my answer. Can I do that? Yes or no? Simple one, right? Just go ahead, go ahead, go ahead, go ahead till they meet. That's your answer, right? Problem comes when one of the side is longer. So it's not a perfect Y, but one of the side could be a lot longer than the other. Okay. Try to use the same thing that we have done in the previous one when they were equal. Can we somehow modify the question and exactly do the same? Right. Some people have given the answer. Others also think. Right. So if we just note down the length of the list, so 1, 2, 3, 4, 5, 6, 8. This side 1, 2, 3, 4, 5, 6. And I take a difference of them. Can I say that is extra length in one of them? Yes or no? So I just run one loop, go to the end, find the length. run another loop, go to the end, find the length, take the difference. This is the extra length in this. Can I just move that much extra length and then do exactly equal y stuff? Yes or no? Now it becomes equal, right? If I just traverse this extra length, now it becomes equal, and I can just do one step and reach the middle. Okay, but this takes 3 iterations. Can we do something much better than 3 iterations? Right. So someone has given a good point. Let me just join this with this. Now what does it become? It becomes finding the starting point of the linked list, loop in the linked list. Can everyone see that? When I join this with this end, then this becomes finding the starting point of the linked list, which we know we can do with fast and slow pointer and then finding the center. Okay. So that could be the third idea. Great. I think many of you already have done some questions like this, so that's great. And if you were thinking it off the bat, then that's much more greater. Yeah. So what you can do is I'll give some problems, like it's almost all of them are there on the dashboard. What you can do, you can try to do some of those problems and try to get it submitted and revise some more portions. Like some of you were asking about LRU cache. If you want, you can study that as well from the dashboard. And yeah, we'll start tomorrow. I think the main topics left are some of the algorithms. I think searching, graphs. What else important is left? I think heaps and greedy is also not done, right? Heaps, etc. is not done. Queue is a very small topic. I'm not sure we should cover that. Like not a very important topic as well. Arrays, arrays questions, but again, not super important for interviews. So I think graphs and yeah, graphs, binary search, and heap and greedy a little bit. This is left. Also, hashing is left, right? Little bit of hashing, if I'm not wrong. Yes. So yeah, I'll try to figure out what best we can do in the remaining days and try to cover those. I think let's start with graph tomorrow. We'll do at least the basic algorithms, DFS, BFS, and questions on those, right? Then we can move on to the remaining topics. Actually, searching is also very important. Probably we can do searching first and then graphs, and then we can wrap up with the remaining topics. Okay then. Bye bye everyone.